Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus Shahawi. My metric number is 30555. So today I will present the first question from the first semester session 2022-2023.
Question 1. Given an equilibrium for combined goods market and equilibrium for money market of hypothetical open economy as follows. So they are given two equations, equation 1 and equation 2. Question A. Take the total differential of the general implicit form of both equations above. So in order to find the total differential, we can write down for the first equation df1 equal to 0 and for the second equation df2 equal to 0. So here we can differentiate the endogenous variable and then the exogenous variable. So we get partial derivative of f1 with respect to y times dy plus partial derivative of f1 with respect to r times dr plus partial derivative of f1 with respect to mo times dmo plus partial derivative of f1 with respect to xo times dxo equal to 0. And for the second equation, we can get df2 equal to 0 for the total differential for the second equation. So we can differentiate the endogenous variable and then followed by the exogenous variable. So we get partial derivative of f2 with respect to y times dy plus partial derivative of f2 with respect to r times dr plus partial derivative of f2 with respect to mo times dmo plus partial derivative of f2 with respect to xo times dxo equal to 0. So for the question B, take the total differential of the specific implicit form of both equations above. Just now we just find the total differential of the general implicit, and now we have to find the total differential of the specific implicit. So we can write df1 equal to 0, and then we have to find the partial derivative of f1 with respect to y times dy, and then partial derivative of f1 with respect to y equal to negative xy minus zy, and then times dy plus partial derivative of f1 with respect to r, we get the ir minus sr minus zr times dr, and then plus partial derivative of f1 with respect to mo. So when we differentiate, we will get 0 because of there is no mo in these equations. And then we find the partial derivative of f1 with respect to xo, we will get 1 this, and then times dxo equal to 0. And then the second equation, we can write it as df2 equal to 0. So df2, so we find the partial derivative of f2 with respect to y, and then we will get the ly from these equations. And then we find the plus partial derivative of f2 with respect to r, we get the lr times dr, and then plus partial derivative of f2 with respect to mo, we will get the negative 1 times dmo, and plus the partial derivative of f2 with respect to xo, so we will get the 0 because of there is no xo in these equations.
So for the question 1, assignment 3, part C, express in the matrix form Gx equals to B the total derivatives of the both the general and specific implicit obtained in A and B with respect to xo. So right now we write that df1 equals to negative sy negative zy dy plus ir negative sr zr dr equals to negative dxo. And then since the question mentioned that with respect to xo, we will put dxo bottom from the dy, dr and negative dxo. So we will put negative sy negative zy dy over dxo plus ir negative sr negative zr dr over dxo equals to negative dxo over dxo. So we have the equation that suit the question, and then we will apply the same step for the df2. So ly dy over dxo plus lr dr over dxo equals to negative dmo over dxo. So this is our equation. And then for the matrix form of Gx equal to B, we have J negative sy negative zy, lr negative sr negative zr, and ly lr. And then for our x, we have dy over dxo, and bottom we have dr over dxo. So our B, the final part, is negative 1. How do we get negative 1? We will look back at the negative dxo over dxo. We can simplify it and we will get negative 1. And then for 0 right here, we will get from negative dmo over dxo. So our final answer will be like this: Jx equals to D. So for the question D, we have the question to find the J determinant and determine its sign. So before that, I list down the node Ly bigger than 0, Lr less than 0, Sy and Zy is between 0 and 1. This will be useful after this. So right now we have the J, we have negative SY, negative ZY, IR, SR and ZR, then LY, LR. So how do we do this? First we write the J determinant, then we put this symbol. This symbol will get from the node that we have listed. So for example, we'll take LY, the symbol is positive because right here LY is bigger than 0, so it is positive, and LR is less than 0, so the symbol we will write down is negative. And then we'll apply the same method to the SY, ZY, IR, SR and ZR. Then we will get the symbol for them, which is negative, negative, plus and negative. And then we will use the AD minus BC right here to find the determinant. 2 times 2, we get the answer right here is positive. So we can conclude that the sign for the J determinant is positive.
So the question E asks, measure the effect on the equilibrium level of income and interest rate of a change in the autonomous export at 0. So the first thing first, the change in income. So dy over dx 0 equal to J1 over J. So we got here negative, negative, 0 and negative over plus. And then we got, after we solve, we got positive output here. So the next is we find the change in interest rate. So dr over ds 0. So yeah, we use J2 over J. So we got here negative, negative, positive, 0 over plus. We got the answer is positive. So this means the first one, income and autonomous export is positive relationship, and the second one is interest rate. We got positive relationship also. Okay, the second question is question F. Comment on finding in E above. The question E, right? So when the income increase, the autonomous export also increase. So what we can see here is there is a positive relationship between income and autonomous export. And the second one is interest rate. So when the interest rate increase, then the autonomous rate also increase. So we can see a positive relationship between the interest rate and autonomous export.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fidos bin Abdul Hadi and my matrix number is 300745. So I'm going to explain about question number 2 in assignment 3. So the first question is given an equilibrium quantity Q of a hypothetical market model for a commodity as follow. So first question is partially differentiate Q with respect to PS. So we divided the Q equation into V, U, V inverse and also U inverse. Which means differentiate. So V will be F plus B and U will be FCPS. Why only FCPS? Is because if we differentiate if we differentiate FA, FE, FDPC and also FGPI with respect to PS, we will get 0. Okay, so F inverse will be F plus B times FC minus 0 times FCPS divided by F plus B square, and then we can eliminate the 0 and FCPS. And then we can eliminate also F plus B and also the square on the below side, and we will get FC divided by F plus B. Okay, so next question, referring to your findings, state the direction of the relationship between Q and PS. So since it is stated in the question A, B, C, D, E, F, G is more than 0, so we can conclude that FC and also F plus B is more than 0. Thus we can, if it is more than 0, we can conclude that the relationship between Q and PS shows the positive relationship and also positive direction. Okay, so C, briefly explain the effect of change in PS on Q. So since we know that Q and PS have positive relationship, so an increase in the price of substitute PS will also increase the equilibrium quantity. Also, and a decrease in the price of substitute will decrease the equilibrium quantity. This is due to the fact that PS and Q have positive relationship between them. So I think that's all from me. Thank you. Assalamualaikum.